You know, when you look up at the night sky, you see these quiet, fuzzy patches of light. But what if one of those serene-looking objects is actually locked in a cosmic dance of creation and destruction? Today, we're diving into Messier 1, a star cluster that's hiding a surprisingly violent secret.
And there it is, about 14,300 light-years away in the constellation Ophiuchus. We've got Messier 10, or M10 for short. It's what astronomers call a globular cluster. Just picture this massive, spherical city packed with hundreds of thousands of ancient stars, all held together by gravity. It's been drifting through the cosmos for billions of years, looking like this timeless monument in our galaxy.
And this is where our story really kicks off, because M10's journey isn't just some gentle float through space. Oh no, it's a dramatic, repeating plunge through the most dangerous neighborhoods of our galaxy. This beautiful, peaceful-looking city of stars is actually being slowly dismantled, orbit by orbit. To really get what's happening here, we have to talk about its path. This isn't your standard run-of-the-mill orbit. It's something much more complex, and, as it turns out, way more beautiful. So most of us are familiar with a simple elliptical orbit, right? Think of the Earth going around the sun. It just follows the same track over and over again, a predictable loop, all thanks to gravity. For a long time, we kind of thought most things in space worked like this. Simple, clean, and repeatable. But here's the crucial point. The universe is a messy place, and gravity is a really complicated force. And as astronomers have figured out, those perfect, neat orbits, they're more the exception than the rule. And M10 is a perfect example of why. Do you remember spirographs? Those awesome toys that let you draw these incredibly intricate patterns? Well, imagine trying to draw just a simple ellipse, but with every single rotation, the whole thing shifts just a little bit. You wouldn't get a single clean line. You'd get this beautiful, overlapping flower-like pattern. And that is exactly what's happening to M10. Its orbit around the center of our galaxy isn't a simple repeating loop. Every 140 million years, as it completes one full circuit, its path shifts. It never quite comes back to the same spot. So, what does that spirograph pattern look like in real life? Well, check this out. This is a model of M10's orbit from a key research paper. You can see it plunging in and out, swooping up and down, carving out this incredible Rosette pattern over billions of years. It's just amazing. So, it's a beautiful orbit, right? A real cosmic work of art. Well, yes, but this beautiful dance has a dark side. Each one of those graceful swoops through the galaxy comes at a terrible, terrible price. This is the big question asked by the astronomers who modeled M10's orbit. See, its path forces it to punch right through the dense, flat disk of the Milky Way. That's the part where we live. And it turns out that is an incredibly hazardous trip to make over and over again. Now, you might think the danger is from collisions, M1 smashing into other stars, but space is just unbelievably empty. That's not really a risk. The real threat is something way more subtle, but also way more powerful. It's gravity itself. The intense gravitational pull of the entire galactic disk acts like a tidal wave, trying to rip the cluster apart. Scientists have a name for this: tidal shocks. As M10 passes through the disk, the galaxy's gravity pulls harder on the side of the cluster closer to it than on the far side. This difference in pull stretches and distorts the cluster, and every single time this happens, some of the stars on the outer edges just get stripped away, lost to the cluster forever. So how big of a deal is this really? Well, let's put some numbers on it. If M10 were just left on its own, slowly losing stars through its own internal processes, models predict it would survive for about 24 billion years. A good, long life. But when you add in the effect of these repeated tidal shocks, its lifespan gets cut down to just 18 billion years. That's a 6 billion year chunk of its existence just gone. That really hammers home just how destructive these plunges through the galactic plane really are. Okay, so this all sounds pretty fantastic, but it begs a huge question. How on earth could we possibly know any of this? Incredibly, the answer lies not just in supercomputers, but in these fragile artifacts from the early days of modern astronomy. I mean, just think about it. We've only been watching the skies with good telescopes for a few centuries. M10's orbit takes 140 million years. The motion we can actually see is minuscule. It's tiny. So how do you build a model of its entire epic journey? Well, you need a very, very long baseline of observations.
And this is where we get it. These are glass photographic plates from the 1930s. Yeah, before digital cameras, this is how astronomers captured the sky. By digitizing these nearly century-old images and comparing them to modern ones, astronomers could create a time-lapse spanning decades. It gave them just enough data to track M10's tiny crawl across the sky and then model its future path. But working with this old data was a massive headache. The scientists who digitized these plates, they had to deal with all sorts of problems. Stains, fog from scattered moonlight, fading emulsions. They even think some plates had a nicotine hue from, get this, someone smoking while inspecting the plates decades ago. It's true astronomical detective work. So let's piece this all together. You've got the first observations from the 1930s. Decades later, those old glass plates are carefully scanned and digitized. All that data from that long baseline gets fed into these powerful computer simulations. And what comes out the other side? We get the stunning Rosette orbit and the cold, hard numbers on how these tidal shocks are shortening the cluster's life.
So we know M10 is on a destructive path. But what does the future really hold for this ancient city of stars? Is it just doomed to completely dissolve? Well, the answer is a little more complicated, and honestly, pretty fascinating.
Okay, this is one of the coolest parts of the whole story. It turns out the process of destruction is actually self-limiting. As M10 loses its outer, more loosely bound stars, the core that's left over becomes tighter and more compact. This actually makes it more resilient to the next tidal shock. In a way, the cluster is hardening itself against the very forces trying to tear it apart. And this leads to a really poignant conclusion. If the shocks have less effect on it now, it means they must have been far, far more effective in the past. The M10 we see today isn't what it once was. It's a survivor. We are literally watching the final slow-motion stages of a dissolution that began billions of years ago. We're looking at the ghost of a once much grander city of stars.
So the big takeaway is this. That serene-looking star cluster is anything but. It's a survivor of an incredibly violent path, and it's tracing this beautiful but deadly path through our galaxy. It really makes you wonder, doesn't it? As you look up at the sky, what other seemingly peaceful objects out there are hiding their own incredible stories of cosmic survival, just waiting for us to connect the dots?